Hello, statistics students. It's Professor Ken, and here I am in Egypt, and behind me is the world famous Sphinx. Oh, I can't move my, it's not letting me move to show you the Sphinx. So, but you're gonna have to, oh, wait. Oh, well, never mind. Anyhow, I'm here to show you how to estimate the proportion of a population if we know the proportion of a sample. So I'm going to do this. I'm going to teach this to you by giving you an example, then going to Desmos and showing you how Desmos can help us to do this. So the first thing I'm going to do is share my screen. Okay. And the next thing I'm going to do is to turn off my camera so my good looks don't distract you. For whatever reason, I'm still there. Okay, well, I guess my good looks are going to distract you. Okay, so let's go to a whiteboard. So I'm going to go to Microsoft Whiteboard. There it is. Gotta wait for it to boot up. Here it comes. New whiteboard. Okay, and I'm going to use text. Okay. Suppose we want to know. Got it. All right. Okay. That's way too big. How do I make this thing smaller? Okay, so suppose we want to know what percent of men over 35 are bald. Estimate the world's population of bald men over 35. Based on a study in which 75 men over 35 were sampled, and 15 of those lucky guys were bald. Okay, here we go. So let me get my pen now because that girl messed up my settings. Everything is so darn big. And I'm doing control minus and nothing's working. But that's okay because it scrolls on forever. All right, so choose my pen. So what do we know? We know that n is equal to 75 and p hat, not fat, but p hat is equal to 15 over 35. And one of the things I did not tell you was to make a 95% confidence interval. Okay, so there it is. Don't ask me how it went over there. All right, so how do I get rid of this? Hold on. All right. So we need to know that p hat is 15 over 35, and we need to know that n is equal to 75. Now that we know that, let's go to Desmos. Let's learn together. Okay, now I'm logged in, but this isn't what I want. I want to find out how to do not the population means, but the proportions with margin of error. Okay, so I'm going to open this graph. And what's my p-value? Let's go back to that whiteboard so we can remember 15 out of 35. All right, My N is 35. And what's going to be the area of my right tail? Well, if I'm doing a 95% confidence interval, it's going to be 0.025. So the area to the left is going to be 0.975. Okay. So my Z value is 1.96. My error value is 0.02. Oh, hold on. That says 0.15 out of 30. I knew there was something wrong. Okay. Okay. My lower value is 26.5 and my upper value is 59.3. How about that? So we are done. All right. So we want to go back to our answer. So once again, we just had to put in our p-value, which was 15 over 35, our n value, and what we've just discovered is that, oh, by the way, if I put a negative z here, capital Z, and a positive z here, we see that the area under the curve, the shaded area, is 95%. Since we're doing a 95% confidence interval, that gives us a good idea that everything is great. So it's 16.4%. Here's what we would write. 16.4% is less than P, which stands for the proportion for the world of men over 35, which is less than. I'm going to check my answer again because I don't want to leave anything. The lower limit, no, E was 16.4, the 26.5. I have to erase it, but I don't see any erase feature. Oh, there it is. So it's 24.5% is less than P, which is less than 59.3%. So that's a pretty wide range. And the reason why it's so wide is because our N value was so small. It was only 35. So our upper limit again is 59.3.
Relax, I'm going here.
Okay, so what does this mean? It means that with 95% confidence, we can say that the proportion of lucky bald men over 35, I'll just write bald men, over 35 years old is between 24.5% and 59.3%. All right, so that's one of the questions you're going to have on Thursday's quiz. Right, let me stop the share. I'm back again. Okay, so I hope this helps you to get a better understanding of how to estimate the proportion of an entire population. And when we're estimating the proportion of an entire population, we get a range, which is called the margin of error. Okay, this is Professor Ken signing off.